Would like to very warmly welcome everybody who's already joined and more delegates and more industry friends who are about to join this webinar. On behalf of ELCINA, my name is Raju Goel, and I would like to welcome all the participants here. And this webinar is being hosted under the aegis of the ELCINA Semiconductor Special Interest Group, which we are doing various activities under this group. And this webinar is on conductive ink, inks and flexible electronics. I think these are all new technologies of great interest for the semiconductor and for the electronic sector. So I would like to warmly welcome, Dr. Sudhir Kumar, our speaker. We have Dr. Sudhir Kumar, who is the COO of the National Center for Flexible Electronics. This center is, one of, I would say, the important organizations which is developing flexible technology. It has been promoted and sponsored by the Ministry of Electronics and IT, and it was actually inaugurated as long back or announced, I think, in the year 2015 by the Prime Minister himself. The center has been operational since 2018, and Dr. Sudhir Kumar has been managing and running the center and developing all kinds of new things here, and he will talk more about it. In one line, I would like to say that the center is focused on products or components like transistors, batteries, sensors, OLEDs, solar technology, etc., all of which is being developed in a printed format. So that is about Dr. Sudhir Kumar, and we have Dr. Ashwani Agarwal here, who has been in with the industry now for more than 40 years. He was with HP earlier, then he was with, I think, several companies, and lastly he has been with Applied Materials, which is a global leader in semiconductor equipment. So he was a director there, and he retired only very recently. He is now wearing several hats. For example, he is a professor in the Manav Rachna University. He also leads the Semiconductor Interest Group in ELCINA, and he is also with ESSCI. So he is working very actively in skill development and also in the supply chain areas. So with that introduction, I would like to welcome everybody once again. I have my colleague, Sandeep also, Mr. Sandeep Saxena, who's also here. So he will be there on behalf of ELCINA in the webinar. And I welcome all of you, and I wish you a very fruitful 1 hour. So over to Dr. Ashwani. You would like to say something about the Semicon India, which is coming up, and then over to Dr. Sudhir Kumar.
Thank you, Raju, for a warm introduction, and thank you everybody for joining us here. I can see the audience number rising, and it is my pleasure to actually give you the background for this webinar. This webinar is actually one of the preparatory webinars we are doing to promote Semicon India 2024, which is an ELCINA partner doing Semicon India at India Expo Mart next month from the week of 9th, 11th to 13th is the actual show floor and the exhibition in Greater Noida. One of the topics in that particular event in the conference is going to be future technologies. And the future technology that we will be presenting there, among others, will be flexible hybrid electronics. And Sudhir and I are speakers on that, keynote speakers on it. We'll be giving a snapshot of what we're going to talk there here, just to whet up your interest. But let me start by telling you about Semicon a little more. Semicon is world's biggest semiconductor industry event. It is now running in the 8th. It's running actually in 7 countries, and now India is joining as the 8th participant in that franchise. This year, Semicon is a mega blockbuster. We have 750 companies at Electronica, 250 of which are semiconductor companies, and this is roughly 8 times the size of Semicon that was there last year. Okay, we expect a daily footfall of between 50,000 to 1 lakh is a number that I have heard recently that will actually take place. The hotels in the city are totally booked out. There are hotels now closer to the venue who are now asking for a lakh of rupee a night for their rooms. And that can give you an idea of how big this event is going to be. There are academic institutions, and I'm sure if you are from academia, your institution is aware that there is going to be a job fair there. With the growing interest in semiconductor industry, I am aware of at least 3 institutions who are planning to have complete teams out there scanning and manning the entire network of companies who are there to see where the job opportunities can rise for their students. And therefore, there's a lot of interesting promise that is building up. I guess all I can say is be there, network, pick up the links. The future is getting created out there. On that note, let me invite Dr. Sudhir, uh, my old friend and industry estate, head of National Center for Flexible Electronics, for his intro note on flexible electronics, and then we will take over and talk a little more about it. Back to you, Sudhirji, your
Thank you,
audience,
thank you,
your
thank you,
presentation.
Dr. Ashwini. Thank you. So, let me share the presentation. I hope you can see the slide.
Yes, we can.
Okay. So good afternoon, everyone, and very warm welcome for joining this webinar on conducting inks, which is used mainly for flexible electronics, organized by ELCINA Semiconductor Special Interest Group today. The main topic of the discussion and the presentation today are displayed in this slide. So the main topic we will be discussing today, which will be presented by my friend, Dr. Ashwini Agrawal, later after my talk on conductive ink. Before going to the main topic, let me give you the brief introduction, brief overview about the flexible electronics, especially the development towards the next generation devices. Let's look at it the conventional electronics first, basically. So all the gadgets, systems, products, what we use today, using the conventional electronics, how they are getting built. Let's look at it basically. So first, what we need the processor or IC, which is getting manufactured in a semicon, which very soon we are going to realize in this country under the semicon missions. The second stage, basically all the components, they are packaged according to the specification. And the third stage is they are assembled together for a particular application. And the fourth stage, basically we see the system and product which we use in our daily life. We can't live without these gadgets even today. So if you look at it, all the steps, the key important steps and overall technology, the conventional electronics, it's very impressive and the performing very well. Performance is great of the final products, but what it takes multi-billion dollars to set up even for the IC manufacturing fab. So it's very expensive affair. There's a lot of challenges. There's a very complex technology, which will happen in our country in the near future. Let's look at it this slide on the flexible and printable electronics now. What are the key steps here? What you need a flexible substrate. It could be the polymer or plastic, maybe the paper, or maybe the even metal sheet with a flexible metal sheet, depending on the application or depending on the component you want to print on them. The second stage, what you need the printer, basically. This is not very different printer, but yes, roll-to-roll printer or sheet-to-sheet printer. Depending on the technology or the component you want to print, you choose the printer, whether it is a screen printer or inkjet printer, or flexo, gravio, or slow die. There's a choice of technologies depending on the components what you want to print. And you see a lot of printed thing in your routine things in your house every day. The third stage, what comes out the roll, which is with the printed components. You are printing using these printers. And the fourth stage, you can make the innovative and the novel products out of that. So this looks fairly simple. Direct fabrication on the flexible substrate. Maybe basically you can use the printing and vacuum technology together depending on the maturity of the technology, because all the processes, all the technologies are not mature enough. It tends to give the high throughput, potentially at a low cost, but performance and stability may be poor compared to the regular electronics because it just started. A lot of scientists, a lot of engineers, they are working on many technologies, processes to build all the processes so that the reliable and the stable products are established. Now, coming to this slide, see, flexible hybrid electronics, like Dr. Ashwani just informed, we are going to have a session in the semicon exactly on that topic. What does it mean? Use best of both worlds, basically. Use the best conventional electronics chips, mount on the flexible substrate, print the circuit, conducting line, or whatever you can do by the printing route, and make the flexible hybrid electronics. There's a huge market today for this sector. Basically, last year, the country has seen a very, you can say, the surge in the hybrid electronics product. For example, the wearable electronics is one of the category of in this sector, basically. So that sector is seeing a surge in this one. There is a huge demand. So you can use even today the part of flexible electronics and part of conventional electronics, making the hybrid electronics, which you will see more and more application, more number of speakers in the semicon in on the session on 12th. Okay. It has huge potential and market even today it exists. So having this overview on conventional, printable, and flexible hybrid, the question will come why basically there is to do the printable electronics. So it could be as obvious as better than existing one. There's several reasons, but if you look at it, the left side block, basically the flexible, bendable, conformal, or lightweight, if you want those where the lot many products needs on those parameter, then you need to have a printable electronics. You need to print the component on the flexible substrate, like you see the example on the screens here. And the bottom side, you see the flexible solar, where the lightweight flexible solars are required for applications like drone or in aerospace sector or many other applications. Basically, you need the flexible electronics. In the recent days, basically, I came to know that this CEO of this company would be coming in the semicon also. They started printing the PCBs. Basically, it's a direct printing of the PCBs. It may be the revolution if they succeed. They are making single layer or double layer PCBs even today, and seeding to the automotive market. Even printable electronics. Basically, the automotive market is looking forward for the printable electronics. In-mode electronics is the key in the automotive market, where right now there is a limitation. You see a lot many gadgets are included in the cars or automobile vehicle, but you see a lot many wires are running here and there. If you have the in-mode electronics or direct printing on, let's say, the plastic on the conformal substrate, you have the process established, then you can see that how the car will look like or your home appliances will look like. That's the potential the printed electronics has. This is the another picture which you see the example of the printable electronics. Then we have seen now the printable electronics is required. Yes, there are a lot of potential, a lot of application, and the market is waiting for that. So what are the basic requirements to do the printable electronics? So let's look at it. Let's say the process, fabrication, manufacturing, whatever you want to call. There's a three key element. One, substrate, like I explained earlier in previous slide, that you need a flexible substrate. The second, equipment, it could be the roll to roll, it could be the sheet to sheet printer. But there is another very key element which is required, which is called the material and ink. If you have three, then you can print and you can make n number of structure, which we are printing at our center, which I will give you the brief snapshot after a few slides. Okay. So the inks and materials are the key and very important, which you have to develop here in the country to have the supply chain robust for to succeed in the printable electronics. Nobody is going to give you the state of the art inks basically for to develop the printable electronics in your lab or something. So you have to have the solution for that. And that is the reason that this today's topic, which Dr. Ashwini Agarwal is going to deliver, that will be focused on the inks. When we talk about the inks comes in the three categories, which is required for the printable electronics or flexible electronics: conductive ink, semiconductive ink, and dielectric ink. If you have the three inks, then you can make any structure by printing. Subject to that, you have the process and technology in place. And today, the discussion or presentation would be focused on the conductive inks, which Dr. Ashwini Agarwal will deliver. Before I hand over to Dr. Agrawal, let me give you the brief snapshot of the center because he requested me to just explain. So the center at IIT Kanpur, what are we doing, what we have? So you can see that in the small block, we have a center which came out from the green field, like Mr. Raju has given in or informed in his intro talk. It is a state-of-the-art facility for the printable electronics, approximately 5 to 6,000 square meter, having the equipment from lab to fab. And lab to fab means you can do the industrial R&D, you can do prototyping, and you can do the pilot production run also under one roof. So in a way that you can say the one-stop solution for printable electronics. To support that, you have a very strong material and electrical characterization as well placed under one roof. If I just give you briefly some of the key technology platform where the center is focusing on, basically is one of those is sensor. Sensor is a very strong group what we are basically developing here, being the printed gas sensor or the sensor for the healthcare sector. Thin film transistors and array, basically these are developed and these are service to the defense organization, ISRO and DRDO. I would say that the center or IIT Kanpur has the unique facility where you can fabricate end-to-end TFTs here on the flexible substrate. The another technology platform, what we have materials and inks because we need ink. You have seen the importance of the ink. You will learn more in the later today. And then printed tracks, we are basically manufacturing or we have developed the printed tag where the one company has taken the technology forward called Checo, and they are manufacturing, they are supplying to the many brands right now. I'll explain you short while. OLED, organic light emitting diodes. This is the second part of the semicon mission, that having the flexible, fabs, or I would say the display fabs in the country. So we are working on the OLED vacuum processes as well as by the printed route. We are mainly focusing on the printable, flexible OLEDs at the center. Printable batteries, we have developed the batteries. Very soon it is going to be the market that one company is already aligned to set up the manufacturing plant there. Having said that one, these are some of the platform what I have explained. This slide, you will see the roadmap of our journey from fundamental research to technology development to the technology demonstration as well as system integration and the productization. So everything is getting done in this center. These many prototypes have been developed here. Some of those at the right side are licensed to the company, which you will see very soon in the market, where company is going to launch few of them. And it is a continuous journey what center is doing here. But the two things I would like to just mention so that you can see the technology which is developed here, that what the value they have created in the market. There's one tag called Checo. It is a Transpac private limited company. Then it is a copy proof tag, and then it is servicing the brands which you see the logos under that Checo. Making good revenue, very good technology, copy-proof technology, which can be used for the brand production and that other program. Another thing is Lithotronics, which is commercializing the inks which is developed at the center. And they have started manufacturing in Noida fairly at a large scale and supplying started supplying to the various industry, but all the labs they are supplying because the people are getting difficulty to find such kind of inks here. With this, I would say let us find a relevant application and work together. We can work. Thank you very much for the patient listening. And with this, I would hand over to Dr. Ashwani. Dr. Ashwani, over to you.
Thank you. Thank you. Let me share my screen and thank you, Sudhirji. Taking up from where you have leaping across the chasm. And let me actually share the title background. There have been a number of consumer behavior models that have evolved over the last few decades. Some very focused on technology, including Venkart's UTA, UT2 model, Unified Theory and Acceptance of Technology. Another one that has been a real classic has been Geoffrey Moore's entering the tornado, which actually treats how when a technology product enters the mainstream, it really takes off and it hits huge numbers. And you've seen it happen with technologies like inkjet printers, mobile phones, Kodak cameras were totally wiped out as some of these technologies came in, or older generation products were wiped out, and a newer genre of technology just took over. Crossing the Chasm is another book by Geoffrey Moore, which actually took up the thesis of what happens when the product is not yet mainstream. How does it cross that chasm? The chasm of no return, the valley of death, in which most products and technologies fall, and only a few reach the mainstream customer. This is a story of flexible printed electronics. Essentially, it's actually a story of technologies which are getting incubated at this point of time, and which have a tremendous implication for the future. It actually evolves from technologies to applications, from applications to markets, and it is this journey which flexible printed electronics is taking at this point of time. Like Sudhirji, I want to stress what flexible printed electronics is not. It is not your conventional PCB manufacturing. So if you create this matrix where you say whether it is a flexible substrate or whether it is a printed process, clearly PCB manufacturing with a rigid substrate and a process where you are etching away the copper laminate layer to create the conducting traces, it's not a flexible printed electronics. Okay, if it is flexible, but you are still only etching away the top layer to create the conducting trace, it's not flexible electronics. Flexible electronics is that specific technology where a conductive ink is deposited additively on a flexible substrate to create components which can be, printed antenna, which can be passive components, which can be active components, sensors, energy source, and of course the logic. Okay, the die. Now, strictly speaking, the IC itself has still got a journey to take before it can come in as a printed IC. So in a lot of cases, you actually evolve a product with the printed traces, and you could end up putting an actual die in the heart of that system to create an application. Flexible printed electronics is a technology which is discovering markets. To some extent, RFID is something we can equate with FPE, though a lot of RFID tags that you see in the market are not printed electronics. They're not having a printed trace for an antenna. They may have a channel which has been used, a coil that has been put up to make that particular device. But principally, RFID tags are a potential key application of flexible printed electronics with a microchip at the heart of it. Okay, so you're now getting a feel how this particular market is actually set to grow. If you just take RFID, it's actually there in all our cars. It's there in so many applications. It's there in the badges of the students. My granddaughters will have it in their ID card, so that we get a message when they enter the school bus, when they enter the school, when they enter specific areas. And clearly, it's a technology which is uncovering markets. And this is actually what Geoffrey Moore's been talking about, that in that initial stage, before it crosses the chasm, the technology is seeking applications. And then some of these applications will hit mainstream. And as you grow that overall opportunity, the volumes will rise and will create that particular market is a big $1 billion market. We are almost there. If you actually take a look at the automotive sector, you are going to see flexible printed electronic products at different parts of the cars. Even today, when I take my car, the demystifier at the back of it, if you remember, there is something like this at the back of a car, uh, a printed finger heater, which is called demystifier. And it's actually very interesting because essentially it's a flexible printed, uh, uh, you know, uh, product which has been put up, electronic product which has been put up at this at the rear windshield, which will actually heat the surface. It doesn't have to heat the entire car. So the power consumption is really very well managed on it. We talk a little more about it because what we are talking of it is a PTC heater, and the technology has evolved so that this heater, it's PTC stands for positive temperature coefficient heater. It's a sort of a thermistor. The resistance varies with temperature, and resistance actually increases with temperature. So what really happens is that it takes a little current when it is heating, but once it has reached the optimal value, the resistance is higher, the current is lower, the power consumption is moderated, and therefore it is actually going to be a very stable, low consumption power device for heating. And these are taking tractions. They found applications in automotive and they are taking traction. You can see a lot of these across in the automotive and other sectors. So screen printed demister, which is the application I just talked of, is a reality. You will also see this coming up as transparent heaters, antennas, in mold electronics. So you actually have surfaces and you actually have, in mold cavities in which electronics is placed. It is conformally coated. You actually create in mold electronic devices, applications, and they are more compact and deliver the functionality with no compromise. And these are all coming in with a sort of future tech that is invading the automotive sector. You will also see this going into energy. Uh, Dr. Sudhir has talked about flexible solar getting incubated at the NC Flexi, and you can imagine the impact if you can heat a particular uh, car surface to warm up the interior of a car. Imagine if you can actually use such devices for energy harvesting, and there's so much of glass all around, you could actually be at a totally different application, a totally different carbon saving application with sort of products that are there. And these are all prototyping and are getting tested in the market. And it's actually a fascinating opportunity which is building up. Healthcare is another sector where flexible electronics is gaining major traction. It is there in mass production already for glucose sensing devices. It is actually being used in capacitive applications. It's being used in tactical applications. It's being used for monitoring the heart rates. And then beyond that, you're going to see applications in gas sensors and non-glucose applications, applications which will test the environment and use that information to monitor the patient outcomes. So you're actually having unique applications coming in because these are products. You can't fit a PCB on somebody, but you can actually take a flexible substrate and it can be conformal and can take the shape of the surface on which it is being placed, and therefore it can have its own applications in real life. So from glucose test strips, which are reaching market maturity, to products which are going to intervene for ECG, for pH sensing, for cholesterol monitoring, you have a whole host of products in this sector which are, at the anvil of coming out to the market. And these are being tested by a wide range of companies. So you have all these products shipping out at this point of time. I have seen some of these uh, PTC products being used for creating, uh, uh, you know, uh, heating wear at NC Flexi for applications and defense. Uh, you can really think of a whole lot of real life products that can be created if flexible electronics was able to integrate all active and passive components to it. But that is not where it is at as of now. It's creating niches, it's creating opportunities, but it is no longer small. If you take the conductive ink technologies, so these is already by and large classified all the key type of ink technologies. You have a range of them. You have, if you really take a look at it, silver inks take the gold. We are in Olympics at this point of time. We just seen the Olympics, so we know what I mean. The largest market share is with silver-based inks. Okay. Then there are, of course, other ink bases which have been used, which have found traction, including at the extreme end, you see the CNT or carbon nanotube tube-based inks. And then you have the P dot PSS, which is created from two polymers. And again, this polymer-based ink has its own functionalities, especially for stretchability applications. What do you really see are there before a range of things which are serving different applications in the market. They can be serving applications which are conventional and therefore require high conductivity because they're primarily deploying a conductive trace in the applied surface. But if you take a look at it, other factors that matter are how stretchable is that trace? Okay, will it break because it has got stretched? Uh, is it printable? Can it be fired from an, let's say, an inkjet and easily get reproduced on a target substrate? Is it durable, or will it get corrupted over a few tries? What is the reliability of this particular product? So if you take a look at it, all these are very relevant factors in shaping the application and the costing of the product. Okay, uh, it's a very important thing. When I say silver takes the gold, one must also remember gold costs, silver costs. So if you compare silver with a copper laminate, yes, your cost will be not a small factor to consider. Though even copper prices are increasing rapidly, but the fact still remains. Uh, you have to take all these factors as you really work out the economics of your system. Printing yield is very important. Uh, like I said, uh, how will that ink that you have created really deliver if it is stored for a particular length of time? What is the nozzle temperature variance that it can accommodate? How will it react to the room humidity? All these are factors which will directly impact the production of the flexible printed system. If you actually look at the ink formulations, flake-based inks are generally cheaper. But as you look at the nano particle-based article alternatives, the sheer rigidity of the process to create that particular product increases costs. And then there are other hidden costs, which could be in terms of how stable the particular product is and how easy is it to be put in a manufacturing process. And therefore, if one were to take a basis of a per unit conductivity, what is the cost? You might still find the silver flake based inks as very attractive. And all these things apart, really speaking, one must understand that you just cannot compare different inks. First of all, the vendors have their own way of operating. They do not give all the data points, and they may not have all the data points. And the manufacturing process is so environmental dependent that even from batch to batch, there could be variances which could make it really tough. But the key message one wants to share here is that yes, there is demand, there are specialty inks, and these would actually create their own niches. So stretchable ink is one broad category. And I've already covered why you need that stretchability. Okay, obviously it is going to target the wearable technology market. It will target your in-mold electronics markets, and this is going to be one big market opportunity which will evolve. Uh, it is something which is a moving target. If you meet one stretchability norm, then you start looking at others, and ultimately the overall proposition evolves. But already there are products in market in tests which seem to be meeting the requirement for a mainstream execution. The big question that remains is, where are the copper-based ink? Copper is cheaper than silver, and copper gives a process advantage in terms of solderability. It's easier to solder on a copper than on silver, which may require very costly electrical conductive adhesives. Okay, uh, it is a lot more sustainable. Okay, uh, copper's weakness is, by and large, it is not that stable. Okay, opportunities, of course, are in terms of specific applications and specific interventions in the manufacturing process that can improve the copper usability in real life. An encapsulation or a protective coating on that copper trace could be one of the ways to go about it. The threat, of course, is the way the world operates. There are competing technologies which are there, which can change the way these products get deployed, and it can actually change the basis for going in for copper-based inks. The conductive ink applications are therefore subject to a few parameters. Okay, depending on the sort of applications they are, these are the 5 factors which will shape the selection of an appropriate ink: the cost, durability, conductivity, stretchability, and digital printability. And by digital printability, we are talking of the process capacity. Will this particular ink be something that can be fired, for example, as I said, from an inkjet printhead? Will it be something which will coagulate or which can survive a storage period, which can be managed on the nozzle temperatures, which will be realized on the digital printing process? So all these are real factors that will shape the application. Another area which has been really emerging is that of 3D electronics. Okay, and this is, as I said, it's actually when you are using it to integrate your trace into the body of the substrate itself. Okay, it will require specific demands, which could be the curing time. It could be something where the temperature itself will be a critical factor in shaping the selection. You typically are looking at creating niches or vias in the substrate on which the conductive ink has to be deployed, and this via filling has to be just appropriate without leaving gaps. And then you have to make sure that the thermal expansion, which is measured by the CTE or the coefficient of thermal expansion, is reasonably aligned to prevent a performance issue uh, in the uh, uh, in the conductive ink and the base substrate. So this, of course, is resulting in huge application areas. You have seen some of the printed sensors which have been developed at National Center for Flexible Electronics, covering gas sensing they had shared. But you can also see other applications which could include touch sensing and haptics, touch and temperature sensing, illumination, temperature and force sensing, and these functionalities will find applications in biotech and other consumer and industrial applications, and can really be a fascinating drive towards that market maturity. If you take a look at it, suppliers have even targeted using ink-based conformal surfaces for EMI shielding. And of course, this will be directly impacted by the cost, because if you are going to use silver, you're actually going to start ending up with huge costs. But There are people who have looked at even non-silver inks for this application, and it again seems to be evolving as a reasonably sizable opportunity in the marketplace. So, what are the key takeaways from this discussion? We are at an interesting stage in the evolution of the flexible printed electronics. At this point of time, there are areas where the flexible hybrid printed electronics is a reality where there is a discrete or there is a rigid IC component that is integrated with the surface. But even other than that, there are applications that are coming live. The conductive ink market itself, IDTechX gave a figure of about $5 billion, but there are a number of other studies which have actually been more optimistic and have said that this market is $10 billion. And between friends, what's $5 billion? The fact remains it's a whopping big market and it is growing at an enormous rate. Both studies suggest that the final market by 2030 will be anything between 30 to $45 billion. Huge, huge opportunity. Flexible printing electronics market is itself estimated at $35 billion last year. Okay, and it's likely to grow to $75 billion by 2030. There is an increasing commercial traction for select applications. Certain sectors like healthcare, automotive, select consumer segments are showing reasonably strong promise. And more players are now crossing the chasm to enter the mainstream markets. Interestingly, while there are not so many new entrants that have been there in the previous years, we expect that to change. Right now, the previous players are the ones who are tweaking their products to achieve a better market fit and are really hitting the goal with that. Innovations that are emerging in digital manufacturing, in new conductive inks, they are all shaping the opportunities as this market goes ahead. Clearly, this market, I think, is all set for taking off. So I will end it, my presentation on that and request you to actually please stay connected. You have my LinkedIn handles, my YouTube channel handle, my contacts here. Please feel free to connect back with me. I really look forward to seeing you at Semicon in the week of 11 to 13. If you are from the academic community, please join us on the tutorials on 9th and 13th. They are free for academia. Okay, there's a nominal charge for the industry, but they are absolutely amazing sessions to interact with and build up the knowledge base as we make this industry come alive. Look forward to making it happen. Thank you. And we can, at this point of time, if Sudhir is there, between Sudhir and me, we are available for taking any queries.
Thank you, Dr. Ashwini and Dr. Sudhir Kaur. We have got some queries in the Q&A box. So maybe if Dr. Sudhir or Dr. Ashwini can take those questions.
See,
one is
yes. I see some of the some of the questions are generic. Definitely that, like Dr. Aswani informed, that we will be sharing the deck for sure. That yes, we are going to have a big session in Semicon. So we will make it appropriate and then share with the participant. There's one question: is it possible to have the RFID by printing route? Yes, definitely. And then what you are asking the terms, it is a matter of design. The question comes basically the cost, or I would say the dumping cost, at what cost the RFID tags are coming in the country. But yes, you can make by conductive ink, and very efficiently you can make by conductive ink. There is one last question. I think it is just a suggestion, I think. Yeah, it is a suggestion of the inks. So we will be happy to have the one or two more questions if somebody has that. Yeah.
There are companies making these inks in India. Liquotronics is an Indian startup that has been incubated by the National Standard for Flexible Electronics, already in commercial production at this point of time, and you had a set of brands that they are servicing, shared in the earlier presentation.
Yes, and Ashwani ji, there's a two more companies which is coming up because very soon you will see that most of the heaters up to the 150, 160 degree where the majority application comes into the play, you are going to see the printed heaters. And there's a company called Keytronics that is also working very well, and you will have that four industry experts. It will not be good to disclose their name now here, then you will hear that what they are doing in this printable electronics. Yes, there is a company who are working in the printed electronics. Applications are coming up like Dr. Ashwani basically shared in the slides. The few companies, and then you will see many more. What is the industry standards? Okay, yes, this is a very interesting question. Actually, the standards in this field, I tell you, this is one of the responsibility of the center that we are we have filed the two standards for the printable electronics, especially in the conductive ink area, and we will take the industry leader helps, and more standards will come. Yes, standards are coming. If you go to the IEC site, you will find some standard, and you will be getting more and more because industry is growing with that. Aswani, you want to have some light on that standard side or something like that?
I think at this point of time, a lot of standards in this are also getting defined globally by SEMI, which is the Global Semiconductor Manufacturing Industry Association, and the Global Flexible Industry Association is a part of SEMI now. So those standards can always be accessed from SEMI website. You write into ELCINA, which is a partner organization with SEMI. We can also try and give you a link there.
There's a few more questions.
So there's one on the advantages of using liquids or powders.
Please take that question. Yes. Yeah.
The liquid thing is actually the key advantage of using a liquid metal gel is primarily that it never solidifies. So if you actually subject it to several extensions, you put it, use that for creating the traces on, say, your, army suit, for example, and there are lots of stretches on it. Even then, it will not change the resistance. Okay, and it is therefore well suited to applications which are going to be having extensive repeated stretches. Okay, like a variable strain sensors on joints could be one application. You could use it in applications in a defense wear application. So the main challenge, of course, so this is the biggest advantage of a liquid gel. And the only thing is you have to be careful because you have to put it by laminating multiple layers of encapsulation with the gel sandwich between them.
There is one question on the printers manufacturer. Yes, there are several actually. So we are using the RK printer, which is a UK based company, but there's a Microtech. There's several printers you will find who are using the conductive inks or the printer suitable for the conductive inks, basically. So there are many.
I think Nagraji has asked a question, can we come out with the standards from India? I think standards are something we could be a contributing party to it. The standards are normally global. The fact is we are just starting our engagement with SEMI in India, and I'm sure we can get our teams to put up, a member on the committees which will shape the standards. And these standards could well be in newer technology areas that would get defined. We'll have to wait for that option to evolve. We are at a very startup stage for our flexible electronic industry.
Okay. So if there is no further question, then we should hand over to Sandeep Saxena ji. Over to you, Sandeep.
I can see like couple of more questions coming
Couple of
up.
more. Okay, good. We
yeah.
can. We'll take it.
Okay, so that's basically like more of the. Thank you. And in fact, Mr. Nagarajan is asking if the standard is basically from IPC. So we can take up Mr. Nagarajan separately with you, right? IPC is within ELCINA's office and well connected with the ELCINA.
Sure. Yeah.
Just like I would like to thank you, Dr. Sudhir Kumar and Dr. Ashwini Agarwal, for taking us through this journey of introducing the flexible electronics and the conducting inks. And we see a lot of action happening from 9th of September onwards till 13th of September. ELCINA is partnered with SEMI and MMI in getting this Semicon India. And we are also curated like a couple of sessions. So you will have more interactive sessions in the week to come, especially on 12th and 13th of September, where you'll be having like Dr. Ashwini Agarwal, Dr. Sudhir Kumar, and other global leaders from the industry talking on the flexible electronic space. And as
more than that, Sandeep, I must
yes.
tell everybody once more. There is a semiconductor manufacturing tutorial that is being run on 9 September at IIT Delhi Research and Innovation Park. There are two courses which are now a part of the AICT revised curriculum. There is a plan to introduce these courses, the industrial safety for semiconductors and vacuum technology for semiconductors will be presented in a day-long program at IIT Delhi on 9 September, and it is free for academia. Please try and join that. Similarly, on 13 September, there is a display manufacturing tutorials which are there at Belgorod College of Engineering and Technology, which is adjacent to India Expo Mart, the Semicon venue. And again, that is free. If you register on the site and select it, you get 1 year complimentary membership to Society for Information Display. And again, that is free for the academia. So with that, again, you can build up a tremendous knowledge base capacity to address these opportunities which are coming alive in India at this point of time. Be there, try and pick up link. Those of you who are from the student community, from the colleges, there's a place to network with the companies that are there, understand what their requirements are. There will be a pull for jobs which will get created. There is a job fair which is going to get announced on 12th by the minister. So make the most of it. And I look forward to seeing you all at Semicon. Thank you. And at the tutorials.
Thank you. Thank you, Dr. Ashwini. In fact, at this point, I would also like to request all the participants that SEMI has agreed to share a couple of courses with ELCINA, right, on free of cost basis. And we'll be putting up those links on the ELCINA website. So please stay tuned, be connected and check the ELCINA website. And very shortly, you will have a dashboard where it will take you to the SEMI University for all the courses which they have given to the ELCINA members and the community of, and basically the Indian university students. So stay tuned, and there will be like a lot coming up on the semiconductor tutorials. There will be a lot coming up on as part of the semiconductor SIG. We will be organizing a lot more of these webinars in the coming time. And thank you very much. Thank you very much, Dr. Ashwini Agarwal. Thank you very much, Dr. Sudhir Kumar. Thanks a lot. And thank you all the participants.